It's wonderful to hear about your positive experiences and the value you found within this community. Access to shared knowledge and collective experience can be incredibly beneficial for professional development. Your dedication to learning, both in the office and through hands-on volunteer work, is commendable. Combining theoretical knowledge with practical application is an excellent approach to mastering any skill. For those who may want to continue their electrical skills and journey, there are many aspects to consider. Firstly, electrical theory is important. Understanding the fundamental principles of electricity is essential. This includes concepts like voltage, amperage, resistance, Ohm's law, and Kirchhoff's laws. Voltage, measured in volts, is the electrical potential difference that drives current through a circuit. Amperage, measured in amps, is the measure of the electrical current flow. Resistance, measured in ohms, opposes the flow of current. Ohm's law describes the relationship between voltage, current, and resistance. Voltage equals current times resistance, or volts equals amps times ohms. Kirchhoff's laws, including Kirchhoff's current law and Kirchhoff's voltage law, are fundamental principles for analyzing electrical circuits. Secondly, familiarity with the National Electrical Code, or NEC, is a must. The NEC is a comprehensive set of standards for safe electrical installations. It covers everything from wiring methods and overcurrent protection to grounding and bonding. Understanding and adhering to the NEC is crucial for ensuring safety and compliance in electrical work. Thirdly, wiring methods are important. Various wiring methods are used in electrical installations, each with its own advantages and disadvantages. Common wiring methods include Romex non-metallic sheathed cable, which is often used in residential wiring, and conduit such as electrical metallic tubing EMT or rigid metal conduit RMC, which provides mechanical protection for conductors. Selecting the appropriate wiring method depends on factors such as the environment, the type of building, and the applicable codes. Fourthly, overcurrent protection is critical. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. These devices interrupt the flow of current when it exceeds a predetermined level. Selecting the appropriate overcurrent protection device requires careful consideration of the circuit's ampacity and the characteristics of the load it serves. Fifthly, grounding and bonding are very important for safety. Grounding and bonding are essential for minimizing the risk of electrical shock and ensuring the proper operation of electrical equipment. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to trip and de-energize the circuit. Bonding connects non-current carrying metal parts of electrical equipment together to create an electrically conductive path, reducing the potential for voltage differences and shock hazards. Sixthly, electrical components need to be understood well. A wide range of electrical components are used in electrical systems, including switches, receptacles, lighting fixtures, and appliances. Understanding the function and operation of these components is essential for proper installation and maintenance. For example, switches are used to control the flow of current in a circuit, while receptacles provide a convenient means of connecting electrical devices to the power supply. Lighting fixtures convert electrical energy into light, and appliances perform various functions using electricity. Seventhly, reading and interpreting electrical drawings are important skills to have. Electrical drawings, also known as blueprints or schematics, provide a visual representation of electrical systems. These drawings show the layout of circuits, the location of electrical equipment, and the wiring connections. Being able to read and interpret electrical drawings is essential for understanding the design and installation of electrical systems. Eighthly, troubleshooting is key. Troubleshooting involves identifying and resolving problems in electrical systems. This requires a systematic approach, starting with gathering information about the problem, such as the symptoms and the circumstances under which it occurs. Then, testing and measuring electrical parameters, such as voltage, current, and resistance, can help pinpoint the cause of the problem. Finally, repairing or replacing defective components can restore the system to proper operation. Ninthly, safety practices are a must to know. Working with electricity can be dangerous, so it's essential to follow safe work practices to minimize the risk of electrical shock, burns, and other injuries. Safe work practices include energizing circuits before working on them, using insulated tools, wearing appropriate personal protective equipment, and following lockout/tagout procedures. Tenthly, continuous learning is key. The field of electricity is constantly evolving, with new technologies and techniques emerging all the time. Therefore, it's important to stay up to date on the latest developments by attending training courses, reading industry publications, and participating in professional organizations. Seeking guidance from experienced electricians and engineers can also be valuable for learning new skills and advancing your career. Electrical systems operate on a variety of voltage levels, each suited for different applications. Common voltage levels include 120 volts, 208 volts, 240 volts, 277 volts, and 480 volts. 120 volts is typically used for residential lighting and small appliances. 208 volts is commonly found in commercial buildings for powering equipment such as HVAC systems and electric ranges. 240 volts is often used for residential appliances such as electric water heaters and clothes dryers. 277 volts is frequently used for lighting in commercial and industrial buildings. 480 volts is commonly used for large industrial equipment such as motors and machinery. The selection of the appropriate voltage level depends on the power requirements of the load and the distribution system. Wiring sizing is crucial for ensuring the safe and efficient operation of electrical circuits. The size of the conductors used in a circuit must be adequate to carry the anticipated load current without overheating. The NEC provides tables and guidelines for determining the appropriate conductor size based on the ampacity of the circuit and the type of insulation. For example, NEC Table 310.15b16 provides ampacity ratings for various conductor sizes and insulation types. It's important to consider factors such as ambient temperature, the number of conductors in a raceway, and voltage drop when selecting the appropriate conductor size. Conduit fill refers to the percentage of the interior cross-sectional area of a conduit that is occupied by conductors. The NEC limits the maximum allowable conduit fill to prevent overheating and to facilitate the pulling of conductors. The allowable conduit fill depends on the type of conduit and the number of conductors. For example, the NEC specifies that the maximum conduit fill for 3 or more conductors in a conduit is 40%. Exceeding the allowable conduit fill can result in damage to the conductors and overheating of the circuit. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. GFCIs are typically required in areas where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or AFCIs, are designed to protect against fires caused by arcing faults. Arcing faults occur when electricity jumps between two conductors, creating intense heat that can ignite nearby materials. AFCIs detect the unique characteristics of arcing faults and interrupt the power to prevent fires. AFCIs are typically required in bedrooms and other areas where people may be sleeping. Surge protection devices, or SPDs, protect electrical equipment from voltage surges, which are sudden spikes in voltage that can damage sensitive electronic components. Voltage surges can be caused by lightning strikes, power grid switching, and other events. SPD divert the excess voltage away from the equipment, protecting it from damage. SPD are available in various types, including whole house surge protectors and point-of-view surge protectors. Electrical permits are typically required for electrical work to ensure that it complies with local codes and regulations. Permits are usually obtained from the local building department or electrical inspector. The permit process typically involves submitting plans and specifications for the work, paying a fee, and undergoing inspections to verify compliance with the codes. Performing electrical work without a permit can result in fines, delays, and safety hazards. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical work complies with applicable codes and regulations. Inspections are typically required at various stages of the project, such as before the work is concealed and after the work is completed. The inspector will examine the wiring, equipment, and installation methods to ensure that they meet the code requirements. If any deficiencies are found, the contractor will be required to correct them before the inspection is approved.